All right, welcome to Unit 15.2, Dilutions. So the idea with the dilution is we have a concentrated solution. I've got two of them here to kind of illustrate the point. And when we dilute a solution, we add nothing but pure water. So we're adding our water, and our solution volume goes up. We'll have a larger volume now, but the number of solute particles has remained the same. So we still have the same number of moles or the same total mass of solute, which means that we've now changed the concentration. The concentration has decreased. Again, it's moles per liter. If we increase the bottom number, the liters, our concentration will have gone down. Same number of moles, larger overall volume. So diluting a solution reduces not the number of moles. We still have the same number of moles, but it reduces the number of moles per volume, and it changes our molarity. This can be a very useful skill if you're trying to make a very dilute concentration or a lot of concentrations from the same initial stock solution. So problem solving. Usually we call our concentrated solution the stock solution. You heard me just mention a minute ago. The new solution is called the dilute solution, or the dilution. It has been diluted with water. Common questions you're going to see is ask for the initial concentration of stock solution or the volume of stock solution. How much of that stock solution do we have? Sometimes you'll be asked how much water is added to make the dilution, what the concentration of the dilution, the new dilution is, or what the volume of the new dilution is. These are all common questions when you're working with dilutions. So let's take a look at an example. How many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of aqueous 0.4 molar magnesium sulfate? Okay, well, they're asking for how many, here we go, how many milliliters of our more concentrated solution. Notice how 2 molar is more concentrated than the other molarity, it's 0.4 molar. So they're asking for how much of our stock solution we're going to need. So that's what we're going to start with. Question mark, milliliters, stock solution. Highly advise you to put the abbreviations, stock and dilute. You'll see in a minute. There are a lot of different molarities and milliliters that we're working with. So it really helps to keep track of when you're working with the dilution or the stock. Whenever it's possible, it won't always be, but whenever it's possible, I like to start off with the unit or with the number that only has one unit. So we look up here, we see 2 molar. Keep in mind, molar should be moles over liters. That's 2 units. And we have 0.4 molar. Again, that should be moles over liters. That's 2 different units. If I can help it, I try not to start with a double unit. Here, 100 milliliters, there's a unit that, or a number that only has 1 unit. 100 milliliters, I'm going to start with that. So 100 milliliters, notice I got the DLT for dilution. We're trying to make 100 milliliters of the 0.4 molar, the weaker version of the solution. So that's the dilution. All right, well, I know what has to go on the bottom on the next step. I need milliliters of dilution. I want to cancel out my milliliters. So 0.4 moles per 1,000 milliliters. Why is that? Well, right here, moles per liter. There's our moles per liter, there's our molarity, and we cancel out our milliliters dilution by doing that. Well, that's great. Thank you. All right, well, we're not quite done yet. Again, we're looking for milliliters of stock. I want something that puts moles of magnesium sulfate on the bottom. I don't want that in my final answer. I'm only looking for milliliters of stock. So I want to put moles of magnesium sulfate down here to cancel it out, and milliliters of stock up on top, so that can be the unit I'm left with. Where do I get such a unit? Well, that comes from right here. My 2 moles per liter. That's 2 molar. And voila, I've now canceled out moles magnesium sulfate. I'm left with milliliters of stock solution, and now I've just got my calculation left to do. 100 times 0.4 divided by 1,000 times 1,000 divided by 2. And I come up with 20 milliliters of my 2 molar magnesium sulfate will be needed. So I need to take 20 milliliters of magnesium sulfate in order to make 100 milliliters of 0.4 molar magnesium sulfate. All right, there we go. It's our first dilution. Let's take a look at another one. How could you prepare 250 milliliters of 0.2 molar NaCl using only a solution of 1.0 molar NaCl and water? Okay, so we have our stock solution of 1 molar. That's the more concentrated of the two. And we're trying to make 250 milliliters of a 0.2 dilution. Again, question mark, how much stock will I need? If at all possible, I'm going to choose the value that's by itself. That's 250 milliliters of dilution. I want to cancel my dilution out. I'm not sure why the answer just popped up, but we'll go ahead and solve for it anyway. All right, so there's my 0.2 molar, 0.2 moles per liter. Now I want to cancel out my moles of NaCl. So I get that on the bottom, 1,000 milliliters of stock on the top. Because it's 1 molar NaCl, that's 1 mole per liter. And there we go, our dilution is canceled out. Our moles NaCl is canceled out. And we're left with milliliters stock. Now keep in mind, once you solve for the actual value here, 250 times 0.2 divided by 1,000 times 1,000 divided by 1, that's not the actual answer to the question, or not entirely. They're asking how you could prepare that 0.2 molar NaCl solution, or dilution. We want a total of 250 milliliters. So we need to make sure we answer the question in its entirety, and that would be 50 milliliters of our 1 molar stock and 200 milliliters of water. So we still have to do the dilution part of that solution. All right, let's try another one. If 25 milliliters of water are added to 125 milliliters of a 0.15 molar NaOH solution, what will the molarity of the diluted solution be? So a little different question here. We've got our stock solution of 0.15 molar NaOH, and its total volume is 125 milliliters. We're going to add 25 milliliters of pure water, so we're going to dilute it with 25 milliliters of water. And I'm looking for a solution, concentration this time. So I want moles on top, liters of dilution on bottom. Always good to start with the unit you're looking for. It really helps you when you're starting to set up your factor label, getting the correct units into the right places. So 125 milliliters of stock. We'll start with that. And let's go ahead and get rid of the milliliters of stock first. Here's my 0.15 molar NaOH per liter. That gets rid of my milliliters of stock. It also gets moles of NaOH on the top, which is what I want. Now my dilution, go ahead and get liters in the bottom here. So 1,000 milliliters of dilution is equal to 1 liter of dilution. And finally, my dilution is going to have total volume of 125 milliliters plus 25 more milliliters of water, and that's all for my dilution. Again, I know to put that on the bottom because of my factor label. I've got the 1,000 milliliters of dilution up here. I want the 1 liter on the bottom. If I had the 1 liter on the top, I wouldn't have moles per liter. I'd have moles and liters together, mole liters, which I'm not sure exactly what that is. So I make sure I get my 1 liter on the bottom, 1,000 milliliters on top, and that lets me know, hey, I need to put my total volume, 125 mils, plus 25 mils, also on the bottom so that they cancel out. A lot of times you'll see this value here written over here under your starting value. Not a big deal. That's just people that like to make it all nice and clean. It also doesn't hurt to put it by itself. I know it looks weird with naked units or naked numbers up here, but perfectly all right. Works out just fine. We crunch the numbers and we find that, hey, adding 25 milliliters of water to a 0.15 molar solution will give us a 0.13 molar solution. Here's the true value of doing factor label with your dilutions. It doesn't limit you to just molarity problems. Here we can work with a percent concentration. So what is our concentration in percent volume to volume of 25 milliliters of ethanol that's been diluted to a volume of 150 milliliters with water? Well, again, always start with what you're looking for. We're looking for milliliters of solute over milliliters of solution. It's a volume to volume ratio. So percent solution, milliliters of solute, milliliters of solution. We have a 25 milliliters of ethanol. We diluted it to a total volume of 150 milliliters with water. So our 150 milliliters of solution. Again, it doesn't say we added 150 milliliters of water. It says we diluted it to a volume of 150 milliliters. Multiply that by 100% and we get 17% volume to volume. As usual, practice makes perfect. So take a look, give it a practice. This is a day 1. There is also a day 2. That'll be homework tomorrow night.